So, our main topic today is simple harmonic motion. First of all, we will start with periodic motion. Periodic motion. Okay. So, what is periodic motion? When a body or a moving particle repeats its motion along a definite path after regular intervals of time. It is said to be periodic motion. Okay. Now, this period of time, or rather this regular interval of time, is called period or time period of the motion. Okay, right? Now, the path of periodic motion, the path of periodic motion can be linear, circular, elliptical, or any other curve. Okay, for example, rotation of sun, or rather rotation of earth around sun. Right? Now, a special kind of periodic motion is known as oscillatory motion. Now, the type of motion where there is to and fro, that is to and fro motion is said to be periodic. Now, the thing is, not all oscillatory motions need to be periodic. Okay. For example, the motion of pendulum of a wall clock. In case of motion of pendulum of a wall clock, it has a period, it has a time period. It is oscillatory motion, but not all oscillatory motions need to be periodic. Okay. Now, only when energy is conserved, oscillatory motion is also periodic. That means oscillatory motion can be of two types. One, it can be periodic, where energy is conserved, and it can be non-periodic, where energy is not conserved. Okay? Now, one important factor in case of oscillatory motion is that the force or torque directed towards equilibrium position acting in for a body acting in oscillatory motion is called restoring force or torque. That is, F is proportional to minus x, which implies F is equals to minus kx. Okay? For a spring, K is spring constant. Okay? Now, third point is what are damped oscillations? These damped oscillations are those where energy is consumed due to some resistive forces and hence total mechanical energy decreases. Okay? Now, see, now what we are going to learn about is simple harmonic motion. Okay? Simple harmonic motion. See, if the restoring force is proportional to displacement of body, and always directed to its equilibrium position, it is said to perform SHM. Okay. Now, basically, there are two types of SHM. First is linear SHM. Another one is angular SHM. Okay. Now, our next topic is equation of SHM. See, the necessary and most important condition for SHM is F equals to minus Kx, right? Where K is the force constant. K is known as the force constant for SHM, right? And X is the displacement of body from mean position. Okay. So that means, suppose we have a spring block system and this is its equilibrium position. So here we consider origin, and if it is pulled to suppose another distance where it is x, then the force acting will be in the opposite direction of x. Okay. Now we know that force is equal to ma, that is ma equals to minus kx. That means m into d square x dt square is equals to minus kx. Now d square x dt square is equal to minus k by mx. We say that omega square is equal to k by m, or omega equals to root over of k by m, where omega is the angular frequency. So if we substitute it here, we will get d square x dt square plus omega square x equals to 0. This is our second and one of the most important conditions for SHM. Condition 2 for SHM. This one is condition number 1 for SHM. Condition 1 for SHM. Now, in H.C. Verma chapter Simple Harmonic Motion, objective number 1, question 1, there is a certain question I would like to quote. There is a certain question that I would like to quote. That is, the question says, it is from HCV, objective 1, question 1. There, an equation of motion is given. The equation of motion is F equals to minus k root over of x. And you are given, and it is said that the particle is performing SHM. Particle is performing SHM. So, the options are, first option is, when x increases, k increases. Number 2, when x decreases, k decreases. When x increases, k is constant. Number 3, it is not SHM. It is not SHM. Usually the students tend to say that it is not SHM. This is the student's answer, usually. But there is a small trick in the question. See, we can't just see that, okay, f should be equal to minus kx, and here it is equal to minus k of root x. So, It is not SHM, but in the second equation of this chapter, in first page of H.C. Verma, it is written clearly that the definition of SHM is F equals to minus Kx. So how is this not SHM? See, the thing here is that what we have to do is, what is force, mass into acceleration? Okay. And in the subsequent pages, we will observe that the parameters of motion are defined for SHM. One parameter is acceleration, but we can write the equation of acceleration from here itself, because d square x dt square is acceleration itself. So A is equal to minus omega square x, right? So F should be equal to m into, or rather minus m into omega square x. Here it is given as minus k root x, right? That means here minus k, or rather here the negative signs cancel out. Here we should first cancel out the negative signs. What are we left with? We are left with k is equal to m into omega square into root x. Mass is constant, isn't it? Mass is constant. That means
Yes, sir.
k should be proportional to root x. So, according to H.C. Verma, the correct option is number 1 and not number 4. Okay. Now, it has some discrepancy to it. That is why I have showed you this question. Okay. Now, you'll ask, sir, in physics, we face a very big problem. That is, how to understand which question should be approached in a certain manner. There is one and only answer to this. The more you practice PYQs, the more you will get clarity on these areas. See, more you practice PYQs, more there will be doubts, and I will be solving those doubts. In this way, you will see, you will face more clarity in these topics. Okay, now, so we saw that d square x dt square plus omega square x is equal to 0. Right? Now, what if we solve this? What if we solve this equation? How will we solve this equation? See, we know that d square x dt square is basically dv dt. Now, can I multiply the numerator and denominator by dx? So what I will get is dv by dx into dx dt if I rearrange the terms. Now dx dt is v. So this is v into dv dt. So or rather dv dx, right? So let us put v dv dx plus omega square x equals to 0. That means v dv is equals to minus omega square x dx. So if we integrate both sides, we will get v square by 2 is equals to minus omega square x square by 2 plus c1, where c1 is constant of integration. Now, v square is equal to minus omega square x square plus 2c1. So, v will be equal to root over of minus omega square x square plus 2c1. Right? Right? Now, this, this 2c1 can be manipulated in such a way where can I write that this is omega square into 2c1 by omega square minus x square? Yes or no? I can write this. So from here, I can bring out omega into root over of 2c1 by omega square minus x square. Remember, this 2c1 by omega square is basically amplitude. So, or rather, better to write, it's square. So, v is equals to omega root over of a square minus x square. Okay, see, this from here, can I write? From here, can I write this? That v square is equals to omega square a square minus omega square x square. Right? Now, can I write that v square plus omega square x square is equals to omega square a square? Now divide both sides by omega square x a square. So I will get v square by omega square a square plus x square by a square equals to 1, dividing both sides by omega square a square. This is equation of I had told you this in the previous class.
Says it amplitude.
I want to know what is this equation known as. This is the equation of ellipse, right? That is why the graph of velocity versus displacement, graph will be ellipse. Okay, v versus x graph. It will look like this. Okay, and this will be minus a plus a, and this will be omega a. Okay, there is also a minus omega a portion here. Okay, I'm not just drawing that part now. Okay, you can just extend it here also. Minus omega a. Okay, basically it will look like this, but in a vertical manner. Okay, now what we can do is from this equation I can write dx dt is equal to omega root over of a square minus x square. That is dx by root over of a square minus x square is equals to omega dt. Now integrate this. What will you get here? Sine inverse of x by a equal to omega t plus c2. C2 is the second constant of integration. From here I can write x by a is equal to, sine of omega t plus c2. that is x equals to a sine. Now put C2 is equal to phi. What is phi? Phase constant. A sine omega t plus phi. This is the equation of SHM. Okay. Now what we're going to learn is about the spring mass system. Last day in our offline class, we had learnt about graphs in SHM, projection of uniform circular motion as SHM, and energy of SHM. Right? Now we need to understand something called the spring mass system. Okay. Now, see. Okay. See. First of all, first of all, we will learn about what is a spring mass system. See, when a spring is connected to a block on one side and fixed on the other end, it is the most basic version of spring mass system. It is the most basic version of spring mass system, right? Now, in this case, the spring's stiffness of the spring is determined by a constant called K, which is called spring constant, which is called spring constant. Okay. Now, actually, about motion in 1D and 2D, I'll try to give you some recordings. Okay. In the meantime, you see those recordings. I will give an overview, or rather, I will revise those chapters again later also. But for the time being, just revise those. Okay. Now,
Yes, sir.
see, uh, in case of spring mass system, the time period is given by 2 pi root over of m by k. Okay. Now there is a big confusion with students with f and omega. Remember, f is frequency, omega is angular frequency. F is equal to 1 by t, omega is equal to 2 pi by t. F is also equal to 1 by 2 pi root over of m by k, whereas omega is equal to root over of k by m, as we have seen in our case of SHM also. Okay, clear? Now, let us see a concept that suppose there are two masses. Suppose there is the spring is here and we have two masses. One is kept like this and the other is kept above it. Okay. So, if the system is slightly displaced by x, then the time period of SHM for this will be equal to, this is our second case, this is our first case. The time period of this will be equal to 2 pi root over of m plus m by k. Okay. Next, the angular frequency of this SHM will be equal to root over of A by capital M plus small m. Okay. Now, observe one thing very carefully. If this is the mass M and this is the second mass M, rather small m, which is kept above it. And suppose the friction between these surfaces is mu, or rather the coefficient of friction is mu, and the friction rather is given by Fs. Okay, that is the static friction. So, first of all, what are the forces acting on this? One is mg, other is n, right? Also, it is being acted with an acceleration due to the spring that is equal to omega square x, right? Now, the magnitude of the frictional force between the blocks, if they don't want, or rather we don't want the blocks to slip away from each other, what should it be equal to? That Fs should be equal to m into A of spring. That is, the two forces should balance together out, isn't it? Right? So now we know one thing, right? Right? That A of spring is omega square x. Right? Now what is omega here? Root over of k by capital M plus small m. So I can replace this. Here, this is Fs, right? Now, a point up to which the static frictional force between the blocks prevent their relative slipping defines the maximum amplitude of the SHM. Okay? So the maximum value of frictional force, or rather the static frictional force, Fs max, should be equal to Ma, where A here represents maximum. So rather it's better to mention here as maximum. This is the mod value, because here if you can see, I am neglecting the minus sign which represents the direction, because the direction of frictional force is also technically in the negative direction, just like that of the acceleration. So now what is maximum static frictional force for this? Mu mg. This should be equal to m into omega square into A. What is capital A? Capital A is amplitude. We know that maximum acceleration is denoted by omega square A, right? Now, there is a plus minus situation here. We will not discuss about that because we have put the modular symbol, right? So from here, can I write A, or rather it's better to write A max. A max should be equal to, see, M and M get cancelled out. It should be equal to mu omega square, or rather mu into G by omega square, right? Now we know the value of omega square. So let us put that. So this is the maximum amplitude it can reach, after which it will slip. After this amplitude is crossed, the bodies will start slipping away from each other. Okay. Now let us come to our third scenario. Okay. Our third scenario. See, the purpose of telling you these scenarios is that I want to show you what are the possible types of sums that may come in chain. Okay. So now, suppose we have a spring block system. Right? Where the spring constant is K and another block of the same mass is coming with some velocity V. Is coming with some velocity V. Okay. Right. Now, when these two blocks are colliding with each other, let their velocity be V dashed. So, if you apply principle of conservation of momentum, then then in this scenario, what will happen is the initial momentum will be equal to final momentum. So initial momentum is the summation of momentum of the first body, which is at equilibrium. That means its initial velocity is zero. And the initial velocity of the second body is v, mv. That is equal to final momentum. Final momentum is for the total mass of this unit. Now the total mass of this unit is 2m. So 2m into v dashed. So from here, we can say mv is equal to 2m v dashed. So from here, v dashed is equal to v by 2, right? V dashed is equal to v by 2. Now, it is important to note that the collision happened at the mean position of the new SHM because the spring had its natural length just because before the collision. If A is the amplitude of the SHM, then the velocity of the system at the new mean position should be equal to A omega at mean position. Velocity should be equal to A omega, right? Now, the time period of the new SHM will be equal to 2 pi root over of 2m by k, right? Omega will be equal to root over of k by 2m, right? Now, we have seen that v dash is equals to v by 2. Also, v dash will be equal to a omega by this rule. So, v by 2 will be equal to a omega. Now, we have the value of omega. V by 2 is equal to a into root over of k by 2m. From here, can I write that A is equals to V by 2 root over of 2m by k? That is, it is equal to V into root over of m by 2k. That is, this gives us the amplitude of new SH after a block has striken the original block with a velocity v. Clear? Okay. Now let us come to the concept of combination of springs. Okay. So before going to this concept, I would like to show you some important aspect of this spring mass system. Okay, some important concept related to this spring mass system. See, suppose there is a spring here that is connected to a fixed wall, and you have stretched it with some force F. So a restoring force will act. Let us say that the spring constant is K, right? Now, first of all, stress acting on here will be equal to Fr by A, which is also equal to F by A. Strain will be equal to del L by L naught if the natural length is L naught and the elongation is del L. The elongation is del L, right? Now, y will be equal to, the y is Young's modulus. Will be equal to F by A divided by del L by L naught. That is stress by strain. So y will be equal to F into L naught by A into del L. That means F by del L will be equal to YA by L naught. Now what is F? Kx. F is equals to what? Kx. Here x is equal to del L. Right? That means K into del L by del L is equals to YA by L naught. Right? For a certain spring where deformation is allowed, K will be equal to YA by L naught, which we can write as K proportional to 1 by L naught. Right? So the spring constant K is inversely proportional to the natural length of the spring. That means suppose you have a spring like this, which has a natural length of L. Now, if you divide it into 3 parts, which each having length L by 3, now if the original one had spring constant K, they will have spring constant of 3K each. Now, one thing we learned about stiffness, that is, since K refers to the stiffness of the spring, the proportionality relation between K and natural length suggests that higher the length of the spring, lower is the value of K and lower is the stiffness. That is, these will have more or less stiffness.
More stiffness, like the smaller ones will have more stiffness.
Correct. Very good. The smaller ones will have more stiffness compared to the original one. Okay. Now, about combination of springs. About combination of springs, what happens is, there are 2 types of combinations. One is series and one is parallel. Okay. We will go on to the derivation of one of these combinations. Okay. That is, first let us come to series combination, or rather we may see the derivations of both. Maybe this will not come in your boards, okay, but concept is more important here. Fine. Now, suppose we have two blocks connected to a spring, right? And let's say the center of mass of this entire system is over here. And you are divided it into two parts. Over here. Fine. So one part is over here and the other part is here. Right? Now, what happens is, suppose the original one had a length L, natural length L, and spring constant K. The new one has a length of L1 and this one has a length of L2. Suppose this has K1 spring constant and this has K2 spring constant. I am not saying that L1 and L2 are same now. Okay, I'm considering them as different. Okay, because they might not be the same. Suppose if one mass is bigger, so let us do one thing. We should consider this as M1 and M2. So, if one mass is bigger, the center of mass will not be at the center of this entire system, right? If any one mass is bigger, we all know that, right? Now, one thing we are clear over here, that is L1 plus L2 will be equal to L. That is obvious, right? Let us consider this as our first equation. Also, from center of mass concept, can I write that M1 L1 will be equal to M2 L2? Right? This is our second equation. Now, since we know that K is proportional to 1 by natural length, we can say that KL is constant. That means KL is equal to K1L1 is equal to K2L. This is our third equation. Okay. Now, the time period of the first one is suppose T1, which is equal to 2 pi root over of M1 by K1. And time period of second one is equal to 2 pi root over of M2 by K2. Right? Now, see one thing. If I dividing the second equation with the third equation, what will we get? M1 L1 by K1 L1 is equal to M2 L2 by K2 L2. From here, I can say that M1 by K1 is equal to M2 by K2. From here, I can say that root over of M1 by K1 is equal to root over of M2 by K2. That is 2 pi root over of M1 by K1 is equal to 2 pi root over of M2 by K2. This implies T1 is equal to T2. Okay. T1 is equal to T2. Now, here, then the T, that is time period, will be same for both. Right? Right? Now, from this second equation, can we write one thing? Can we write the equation of L2 from 2? Can we write L2 is equal to M1 by M2 into L1? Right? So, and from third equation, or rather not the third equation, let's take it from the first equation. What we know, L1 plus L2 equals to L. That means it is implies that L1 plus M1 by M2 L1 is equal to L. That is, if I take L1 common, I will get 1 plus M1 by M2 is equal to L. That is L1 into M1 plus M2 by M2 is equal to L. That is L1 is equal to L into M2 by M1 plus M2. Clear till this portion? If it is clear till this portion, then can I say now from third equation, that is KL is equal to K1L1, can I write that KL is equals to K1 into M2 by M1 plus M2 into L. So see this L and L get cancelled out. So K is equal to K1 into M2 by M1 plus M2. Right? Now multiplying both sides, or rather dividing both sides by M1. Rather, this is K1. Okay. This is K1. Now multiplying both sides by K1. Before that, can I write K1 as M1 plus M2 by M2 into K? Is it clear to this portion?
Yes, sir.
Now, if I divide both sides by M1, what will I get? K1 by M1 equals to M1 plus M2 by M1 M2 into K. Right? Now, what do I know? That omega square is equal to K by M. Right? And we also know that K1 by M1 is equal to K2 by M2. Right? We know this. So this will imply that omega square is equals to omega 1 square plus omega 2 square. Sorry, omega 1 square equal to omega 2 square. Right? So that means this will be equal to omega square equal to M1 plus M2 by M1 M2 into K. Right? Fine. Now, can I write omega square as K equivalent or K effective spring constant? Now, K effective divided by K effective uh, divided by the total mass. But in this case, we don't know the formula, or rather the value of total mass, including the spring. So we are neglecting that. So we are just putting M1 plus M2 is equal to M1 plus M2 by M1 M2 into K. Okay. So from this equation, can we get a formula that T is equal to 2 pi root over of M1 M2 by M1 plus M2 into K? Right? Right? Okay,
Yes, sir.
fine. Now, this was our situation here. Okay, this was our situation here. Now, What about direct series combination of circuit? Or rather, sorry, by mistake I said circuit. It's for the spring, right? That is, I have divided it here. In case of series connection, what happens is, suppose this is the fixed part, this is our fixed part, right? Now, one string, or rather one spring is connected here, and the other spring is connected here, right? They are connected to a block of mass M. This is our main series connection circuit, or rather diagram. Connection.
So this diagram is of series.
Yes, because uh, two springs are connected in series.
Yes.
Like we had in resistance, like this. This is for spring. Now, consider that this is K1 and the elongation for this spring is X1, not the natural length. I'm talking about elongation. This is K2 and the elongation for this is X2. Okay. And the net elongation of this body is X. Okay. So X should be equal to X1 plus X2. Right? What is X? F by K equivalent. This should be equal to F by K1 plus F by K2. Right? So 1 by K equivalent will be equal to 1 by K1 plus 1 by K2. Right? That means for generalized situation, for a general case, for series is that 1 by K equivalent for series is equal to summation of 1 I equals to 1 to N 1 by Ki. Okay, right? What about in parallel? What about parallel? See, the diagram for parallel is something like this. That is, one spring is connected like this, and another spring is connected like this. Okay, this is mass M, and the net elongation here is X when it is pulled by a force F. Here it is K1, here it is K2. That is the spring constants. So F should be equal to F1 by E plus F2. What is F1? F1 is the force experienced by this first string, and F2 is the force experienced by the second spring. So F is equals to what? K equivalent into X. This should be equal to K1X plus K2X. So K equivalent is equal to K1 plus K2. Okay. So in case of parallel, general case for parallel is K equivalent for parallel is equals to summation of I equals to 1 to N Ki. Okay. Okay. Now, let us see a very particular case in this combination. Okay. A particular case of combination. Okay. You can take this as a sum. Right? You can take this as a sum, a question. Now, the spring constants are same in these three. The angle between this and this is 90 degree. The angle between this and this is 135 degree. Okay. This is A, this point is A, this point is B, this point is C. Fine. Now, what will be the free body diagram of this case? That is, it will have, now what is our purpose? Our purpose is to solve for the time period of this setup. Okay, the time period of oscillation of this setup. Now, suppose, now see here, we have the center of mass of this block, let's say, right? So, one thing is that it will experience a force in this direction, and in this direction, that is the spring forces, right? Fine. That is this, let's name this as FA, this as FB, this as FC, right? Now, think about one thing here carefully. That is, FC should be magnitudinally equal to this vector, this force vector, right? And this is 45 degree and 45 degree, right? Now, if that is the case, then the component of FA, listen to this very carefully. The component of FA on this green line will be what? Now think about it like this. Component of FA for this case will be FA cos 45. And the component of B in this case will be what? FB cos 45. And magnitudinally it should be equal to minus FC also. So that means net force will be equal to FA cos 45 plus FB cos 45 minus FC, right? So what is FA? Kx cos 45 plus Kx cos 45 minus of minus Kx, that is 2 into Kx cos 45 plus Kx, that is cos 45 is 1 by root 2, that is 2 into Kx into 1 by root 2 plus Kx, right? So what will be F net from here? 2 into Kx, isn't it? Now, not only that, what we are missing out here is one thing. We are missing out one thing over here. Let me tell you. We need to rewrite this equation. You can just cut it from here. We need to rewrite it. What is FA? if this is kx, if this is minus kx, this is positive kx. If A it itself is kx cos 45 degree, if B in itself is kx cos 45 degree, so we have to put kx cos 45 degree into cos 45 degree actually, plus the same thing minus of minus kx, that is 2 into kx into 1 by root 2 into 1 by root 2 plus kx, that is f net will be equal to 2kx. Is it clear? Now, if f net is this, what is effective k? Effective k into x is equals to 2kx. So effective k here will be 2k. So our time period is 2 pi root over of m by k effective. That is 2 pi root over of m by 2k. Okay. Okay. Now consider this angle as theta 1, consider this angle as theta 2, consider the angle here as theta 3, or rather you don't need to consider theta 3. Now tell me, now your homework will be to find time period if theta 1 equals to theta 2 equals to 120. Acha, one important thing I want to tell you, you don't have to worry much about Saturday test because I'm giving you less time. There is less syllabus. That is, the syllabus is still the basic equations of SHM. It even won't contain very deep, or rather the questions of graph, which I have taught just in the previous class. It won't contain those questions. So it will contain very basic questions. Okay, you won't have to worry much about it. Okay, so it will have 14 questions in total, 12 or 14 questions. Okay, so it's just like a DPP. Fine. Now, today's last topic, today's last topic is about a important sum, or rather I will give you this as a homework. Now, tell me one thing, that is probably Saturday at 9:30. Do you have any online class?
No, sir.
Okay, I will take a math class or physics class at that time. Fine. Okay, so I'll give you that
Okay.
homework later. Thank you.
Thank
Any
you, sir.
doubts?
No, sir. Not for now.
Okay.